Good day, everyone. I'm Mom Nicole, and I will discuss the basic counting principle, which is tree diagram. Calculating probability is hard. Sometimes we add them, sometimes we multiply, but often it's hard to figure out what to do. Tree diagram is to the rescue. For further understanding, let's try this problem. Peter tosses a coin 2 times. Find the probability of getting a two-head and a head, then a tail. Let's first discuss the probability of getting a two-head. There are 2 steps. First, draw a tree diagram to show all the possible outcomes. Second, use the tree diagram to find the probability of getting a two-head. How many possible outcomes are there to flipping a coin? We should know that we only have 2 possible outcomes. It's either a head or a tail. Now, to find the possible outcome, here we are gonna construct a tree diagram. Our first toss, we can end up with a head or a tail. So, if our first flip is a head, then our second flip has 2 options, and those options is a head and a tail. So now, our tree diagram are completed. It will help us to find the exact number of possible outcome in this scenario. The first outcome is head in the first flip and head again in the second flip. The second outcome is head in the first flip and tail in the second flip. Our third outcome is tail in the first flip and head in the second flip. And our last outcome is tail in the first flip and tail again in the second flip.
We should know that we only have 2 possible outcomes. It's either a head or a tail. We can also say that each outcome has a 50% chance to occur. Out of 4 possible outcomes, there is only one outcome with a head. This is 1/4 or 25%. Out of 4 possible outcomes, there is only one outcome with a head then a tail. So, this is 1/4 or 25%.
Now, if you really understand our lesson, let's have an activity. Jane needs our help. Jane has 2 pants, a blue and a black one. She also has a white, an orange, and a green t-shirt. Now, how many color combination Jane can wear a t-shirt and a pants? Now, you have 30 seconds to answer. Time's up! And now, let's answer the question. Based on our tree diagram, Jane has a 6 color combination to wear a t-shirt and a pants, right? If you have the same answer, you are very good. This is the color combination. Blue pants and a green t-shirt. Blue pants and a white t-shirt. Blue pants and a orange t-shirt. Number 4 combination, black pants and a green t-shirt. Black pants and a white t-shirt. And lastly, black pants and an orange t-shirt. Now, let's answer the second question. What is the chance that you wear an orange t-shirt and a black pants?
of 6 color combination, there is only one combination with an orange t-shirt and a black pants. So, this is 1 over 6 or 16.5%.
Thank you for listening. Again, I'm Mom Nicole, and may we call on for our next presenter, Mom Roseth Cagara.
Thank you, Mom Vanessa. Good day, everyone. I am Roseth Cagara, and I'm your next presenters for today. Our next topic is all about sum and product rule. What is sum and product rule? It is the probability refers to the methods of figuring out the probabilities of two events given the probability of each event. First, we discuss the sum rule. What is sum rule? If a task can be done in n sub 1 ways and the second one is n sub 2 ways, and if these two tasks cannot be done at the same time, then there are n sub 1 plus n sub 2 ways to do each task. Now, let's have an example for sum rule. The department will award a pre-computer to either CS student or CS professors. How many different choices are there if there are 530 students and 15 professors? The given choices are 530 students plus 15 professors. Now we will just add 530 plus 15 is equal to, right, there are 545 choices. Now, next topic is, what about the product rule? Suppose that a procedure can be broken down at two successive tasks. If there are n sub 1 to do the first task and n sub 2 to do the second task, after the first task has been done, then there are n sub 1 times n sub 2 ways to do the procedure. So now, we have another example for product rule. How many different license plates are there that contain exactly 3 English letters? So there are 26 letters in our alphabet, right? There are 26 possibilities to pick the first letter, then 26 possibilities to the second one, and 26 for the last one. So there are 26 times 26 times 26 is equal to, right, there are 17,576 different license plates. So now, let's move on to our exercise. The first exercise is, a student can choose a computer project from one of the 3 lists. The 3 lists contain 23, 15, and 19, and possible projects, respectively. How many possible projects are there to choose from? First, 57, second, 58, and 59. And now, I will give you 30 seconds to solve this problem. Time's up. The answer will be 57 projects. Good job! You got the correct answers. Let's try more exercise. There are 8 daily newspapers and 5 weekly magazines published in Chicago. If Colin wants to subscribe to exactly 1 daily newspaper and 1 weekly magazine, how many different choices does he have? First, the choices are 13, 40, 24. Your time is up now. Now, the answer would be 40 choices. Give yourself a good job clap. Now, GOODJOB, good job. Good job. Thank you for your cooperation. And now, again, I am Teacher Roseth Cagara, your teacher for today.
Good day, everyone. I am Ma'am Hazel, and I am the third presenter, and my topic is factorial. What is factorial? The factorial function says to multiply all whole numbers from our chosen number down to 1. It uses the exclamation point as symbol. For any positive integer n, factorial means n times the quantity of n minus 1 times the quantity of n minus 2 and so on until we reach the value of 1. 0 factorial is defined as equal to 1. For example, we need to find 4 factorial. We will substitute 4 to the value of n. This gives us the equation of 4 factorial. It is equal to 4 times the quantity of 4 minus 1 times the quantity of 4 minus 2 times the quantity of 4 minus 3. We stop here because 4 minus 3 is equal to 1. 4 factorial is equals to 4 times 3 times 2 times 1, and the answer will be 24. The factorial symbols only affect the number it follows unless grouping symbols are used. For the first example, 3 times 5 factorial. Only the 5 is affected of the factorial. To solve this, we will first find the 5 factorial. Then multiply the result by 3. So, 3 times 5 factorial is equals to 3 times 5 times 4 times 3 times 2 times 1 is equals to 360. In the next example, we have factorial of 2 times 2. We will solve for 2 times 2, then find the factorial of the result. 2 times 2 is equals to 4. 4 times factorial is equals to 4 factorial. 4 factorial is equals to 24. We can also divide the factorials in 5 factorial divided by 3 factorial. We can solve for each factorial first, then divide them. But if we expand it, we can see that we can just divide the common terms, then multiply the remaining numbers. And the remaining numbers is 5 times 4 is equals to 20. The factorial symbol only affects the number it follows unless grouping symbols are used. For example, 2 times 5 factorial is equals to 2 times 5 times 4 times 3 times 2 times 1 is equals to 240. And the next example is quantity of 2 times 5 factorial is equals to 10 factorial. 10 factorial is equals to 3,628,800. Always remember, we must be careful using parentheses. If we have the quantity of 2 times 5 factorial should be equal to 240 and not 3,628,800. Now, let us test you. Find the value of 5 factorial. I will give you 30 seconds to answer it using your calculator. And this is our choices. First, 120. And the second one is 121. And the third one is 122. And the last is 123. Your timer starts now. Time's up, and our correct answer is 120. Good job! Next problem, find the value of 3 times 4 factorial. The choices are 70, 72,
73, and 74. I will give you 30 seconds to answer using your calculator. And your timer starts now. Time's up, and the answer will be 72. Good job! And the last problem, find the value of 4 factorial over 2 factorial. And the choices are 18, 20, 22, and 24. I will give you 30 seconds to answer using your calculator. Okay. Your timer starts now. Time's up! The correct answer is 20. Good job! You get a correct answer. Thank you for listening. I hope you learn a lot from our group.